Good morning, everyone. It is Mrs. Graham, and I wanted to take a few minutes to review some important ideas about amino acids. Now, we first heard the term amino acid back in the start of the year when we were talking about our biomolecules, our molecules of life, our proteins, our carbohydrates, our nucleic acids, and our lipids. And amino acids are the monomers or the building blocks of a protein molecule. So those amino acids bond together. They form what are called peptide bonds, and that will make up a protein molecule. Now, there are 20 amino acids found in proteins in the human body. So, you have probably seen a chart, if not this one, similar to this in your classes that you use to determine an amino acid based on a sequence of mRNA bases. And you probably also learned that 3 mRNA bases are called a codon, and one codon codes for one amino acid. So, for example, UAU will code for the amino acid tyrosine. And I'm sure you practice this in class. And if we look at this chart for a moment, there's a few things to point out. One, many of these amino acids have the ending INE or INE, and that is a good way to know you are looking at an amino acid. Not all of them, but most of them. And you can see I have them numbered here 1 through 20. And I highlighted a few of the important ideas. For example, serine right here is also right here. So there are a number of different codons that will result in the serine amino acid. So for example, right here, we could have UCU, but over here, we could have AGC. So there are actually 6 codons that will code for serine. And because there's 6 different ways to get to serine, and there are, in fact, for most amino acids, many different codons that will result in that amino acid, we use a term here. We call it redundancy. So we say that there is redundancy in the genetic code, meaning there are several different codons that code for one amino acid. Also highlighted on here in blue, I have the word stop. So stop is not an amino acid. It is the last codon in a protein, and it signifies to the cell that the protein is finished, and that protein can be packaged, it can be shipped out of the cell, and go on and do the many jobs of a protein. And again, remember, those proteins are going to result in the different characteristics. So for example, I have brown eyes because I have proteins that code for a brown pigment that give me my brown eyes. So again, those amino acids will bond together and form a protein molecule. Now, I just have a short one here. In reality, protein molecules are thousands of amino acids long, and they don't just form these straight chains. They'll start to bend and fold based upon the different properties of those amino acids, which then give the protein some unique characteristics as well.